Hi everyone. I'm Gal. I'm going to talk about a topic that is not talked enough, I think, about the attacks and security of on-chain governance models. So the reason why we started Hypernative, and I think relates to this talk, is that when you think about security, there isn't one silver bullet or one risk that you want to cover when you are protecting a protocol or a chain. There are a variety of different risks which obviously you want to prevent proactively, but then because you can't prevent everything, you want to monitor the risk and react to risk. So there are a variety of different things that can attack you. There could be smart contract vulnerabilities, private key theft, things that are related to the Web 2 gateway to your protocol, and third-party dependencies. And one of the topics that is not talked about is on-chain governance, because when you think about governance, it's essentially a gateway to change, modify, send funds, or change parameters or code on-chain. And whenever there is a gateway to such a lucrative target, there are many people looking to manipulate that. So in this talk, I'm going to generalize and be high level about some of the things. So if anyone wants more details, please feel free to come after. There are two models today for governance. So obviously, when you want to send funds, when you want to change parameters or code, you can either have a partially decentralized, where basically everyone are voting either on or off chain. And then after the vote is completed, there is a trusted party that basically execute the vote results. And then there is the fully decentralized, where the vote is being carried automatically on-chain. Now, most of the fully decentralized governance basically have two kind of things. They can send value to a specific address, and then they can call a specific function with specific parameters. And I think when, again, from my experience as a security person, when you look at like a way to send funds, and when you're looking at a way to basically inject and run code, this is like the holy grail of hackers, right? Like, and this is why, for example, for financial departments and things, they have very big policies of how to approve, how to verify the recipient of funds. Hackers a lot of times try to basically inject code and run it in a privileged manner, like SQL injection or all sorts of hacks, right? Like this is the holy grail of a hacker, being able to run some code on your environment in a privileged way. And this is a feature of governance, right? So governance is essentially very open to attacks. And two things that we notice that makes it even more is that in most cases, a lot of people are looking at like what is expected. Like there isn't really a monitoring of all the different kind of proposals, but only the ones that are expected, and anyone can essentially make a proposal today. So I'll touch a bit of a few examples that happened in the last year or two of different kind of governance attack vectors, and then a few of the ways that they can be mitigated or at least monitored. There is the legitimate treasury draining, which is essentially a hacker finds a way to obtain a vote and basically make it cost efficient for them to have this vote accepted, where the funds that they are receiving back are more than the effort that it took them. The other part is what we call force, which is essentially manipulating some bug either in the smart contract of the governance or some bug in the some exploit in the process of approving the proposal. And another one that is a bit more happened in the last year, but is interesting. There is social engineering, basically convincing people to vote on a proposal where they think it's legitimate, but it's actually not. So we'll see a few examples of these attack vectors. The first one, which is very simple, is the Signata DAO. Basically, the hacker made sure that they got a majority through buying the relevant tokens and essentially transfer the funds from the treasury of the protocol to their own wallet. So essentially the transfer funds that they have received are higher than the funds that it cost them to actually approve and gain majority. Very simple process. The other part, which is it's an attack that is actually, for us in Hypernative, it's very close because that's actually the first attack that the system catched. It was, I think, in 2022, where we didn't have a UI there yet, we saw it retroactively in the logs. But the Beanstalk is another attack, which there was like $180 million that was stolen in that attack. And the attack happened because, again, the hacker get a majority to carry the proposal, but the way that they get it is through a flash loan. And the problem that was with that process is that Beanstalk basically allow to both do the vote and the execution of the vote in the same transaction. So hacker basically got a majority through a flash loan. They didn't need to repay it because the execution of the vote to transfer the funds to them was in the same transaction, and they were able to manipulate the governance, which, again, limiting it to a two-stage governance proposal would have solved that case. The other very, very interesting case is the Tornado governance hack, where an attacker basically posted a legitimate, or what looked like a legitimate proposal, convinced the community to vote for that proposal, but they were hiding a self-destruct function in that contract, and essentially through another bug in the create2 function, they managed to basically replace the contract after the vote, after the governance proposal vote. So everyone thought that they are voting for something, but essentially after the vote was carried on, a new implementation was injected, which stole some funds. And Odious, which is basically a bug that it's not really a bug, it's a usage error in OpenZeppelin upgradable proxy initialization bug that was actually used at few attacks in the last year. The team forgot to do the right things, and the attacker basically hijacked the contract, the proxy contract of the governance, and drained the treasury, which, again, a monitoring of this specific pitfall would have been able to prevent it. So I think, as you saw, governance is an attack vector. It can be manipulated through many different kind of ways. And when it is manipulated, it's still something that is privileged and is executing something that is malicious, which is a bad thing. And there are various things that could be done to mitigate a lot of these attack vectors. Of course, one of them is basically get visibility, right? Like, you want to get visibility at all the proposals that are being proposed. It's something not clear because, again, there is sometimes off-chain, on-chain components, so you want something that basically know to flag all the different proposals and then run a variety of checks on them, from simulating and understanding the outcome of this proposal to understanding all sorts of malicious things in the bytecode or in the proposer. And you also want to monitor for pitfalls or things that, deployment errors or things that could result in exploitable governance.